Good afternoon, everybody.
Howdy.
This is going to be architecture automation, one alligator at a time. Based on, the title is inspired by a quote from a customer manager who came up with this wonderful explanation, wonderful line that he delivered to a meeting to try and remind everybody that, you know, firefighting is important when you've got a platform that's kind of not entirely stable and people depend on it. But fundamentally, the reason you're here is not to fight fires, it's to get to a point where there aren't any fires left to be fought. So yeah. The fires of the alligators and the swamp is what you're trying to get rid of in the long run. And I like that because the alligator thing comes across as a decent metaphor. And, you know, I spend a significant percentage of my life dealing with situations like this. Because, you know, Shadowcat's a consultancy. Now, the trouble with being a consultancy is, you know, an early stage startup has not that much money, not that much time, really needs to get a product out. Generally, they don't have the budget to pull in experts, to pull in consultants, to all they have the time and money to do is burn as hard and as fast as possible towards getting something that's going to make money. And that's fair enough. Okay, yes, you end up accumulating a lot of technical debt in the process of doing that, but the other point of view is technical debt sure as hell beats running out of money before you get this thing working. Every single customer, every single Shadowcat customer starts off with, "We're really sorry, the code's a bit of a mess." It's like, yeah, and it's also doing something users want enough to be able to make enough money to pay us to help you make it not a mess. You did something right here. But that's the thing, though. Sometimes technical debt is something you can't avoid. Sometimes it's simply the fact that when you started the company, when the company was started, when the team was started, when the project was started, people simply didn't have the experience to realize that they were making a massive mess. When Shadowcat first hired a sysadmin, he took one look at the server that I'd been, well, administrating is probably an optimistic word, because basically it was a question of, in my copious free time, I hit it with a stick until it did basically what I wanted, and then went back to doing customer work. So, you know, I have made such a mess, and it's now been, I think, 7 years since we hired him, and he still won't let me forget the mess that machine was in. Then again, he did manage to find about 120 files called httpd.conf, of which about 75 were integral to the running of the system. So, anyway, so this happens to all of us. But if it's a mess with happy customers, you know, you need to fix it, but you need to fix it while adding features and without breaking it. Okay. It's not as hard as it sounds. Step 0. What servers do we even have? Seriously, I've run into this problem. We know what most of the servers are, but you know, okay, your data center will list them. We'll be able to give you a list if you've got colo. If you've got cloud or a VPS provider, then there's going to be an API. The moment when you pull a list out of EC2 and go, well, I recognize most of these. This is the point at which you realize this is going to be an interesting exercise. But you can start from there. Get a definitive list, because there's always one you forgot about. You know, even in the best managed systems, there's always going to be one that snuck under the radar. And you can absolutely bet production depends on it, and there's no slave. Okay, that done. Step 1. We need to figure out what we're actually running. Aha, there's actually a clock on here. I don't need another one. Cool. Need to figure out what we're running. Okay. Bonus points at this stage if the guy who actually had the system architecture in his head has already left the company. That happens to us about 1 time in 3. On the other hand, often that means his salary ends up being part of our invoicing, so I can't actually complain. But oh god. All right, yeah. So where do you go? Well, you go to the system documentation, obviously, because clearly in a startup that's been accumulating technical debt, the documentation is going to be complete, coherent, and completely up to date. That's bound to happen, right? Not a chance. Though the only real source of truth as to what your systems are running is the systems. So you're going to have to go and ask them. First question is, what's installed? Well, DPKG can tell you, or, you know, if you're in our hell, then RPM can tell you. If you're on Windows, hire somebody else, I don't want to know. Just no. If you're on OS X, then you probably need to ask all 3 of the different packaging systems you had to install to get everything working. I'm not 100% sure of the commands for that one. I dearly love my iMac. I call it the TV. But seriously, there's going to be some way of asking the operating system, so get the lists. For a bonus, this would be a good moment to diff the lists and discover how many different configurations you have. Because I am willing to bet at this stage, if you have 4 web servers, then you'll have at least 3 different sets of packages. But you know, again, you can get the information. Next thing is, okay, your custom code. This is fine right up until the point of you probably deployed out of Git repositories, and again, there will be one service somewhere that somebody checked out of a repository, set up, business is using it. Nobody's asked for a feature on it for a year, so everybody's forgotten it was there. So you need to go hunting. If you want to find repositories, the easy way is literally run a locate for .git directories, or .svn, or whatever. If it's a .rcs directory, welcome to 1995. I'm not entirely sure why you did that. But again, you can find the list. Now you need to figure out where it came from. There's 2 possibilities for doing that, depending on which sort of insane you want to be. You can either parse .git/config yourself, or you can run git remote -v to get a list. What we've generally found is you're best off parsing .git/config first, and then running a bunch of git commands based on the data in that. Because I don't know about anybody else, but I find it very difficult to remember which bits of Git are infrastructure where the output format is guaranteed, and which bits are porcelain where they're going to make it slightly less confusing in the next release, and then the parser's going to break. Whereas .git/config stays pretty constant. And then the question is this a true version of anything? Because it probably isn't, because nobody's updated it for a while. So you're going to want to apply git status and git log to figure out which branch it's from, how many revisions behind is it, and then you must run git diff, because there will be one at least service where somebody, to fix an outage at 3 in the morning, edited the live code on the production server and then forgot to check it in when they got up in the morning. Let he who has never been guilty of these things cast the first stone, but there's always one, so just assume it. You know, my standard rule when doing this sort of stuff is, think about every single stupid and horrible mistake I've made in my entire career, and assume that somewhere along the line we've made all of them on this system. That gives me quite a long list of horrible mistakes to look out for. Often been the joke. Definition of a junior consultant: somebody who sells you the benefit of their mistakes. Definition of a senior consultant: somebody who sells you the benefit of their and their previous customers' mistakes. Anyway, And you're probably going to have package trees in a local lib. Okay, some of you may have built RPMs or debs of everything. I generally find that people haven't because they want the dependencies alongside the application so they can upgrade them independently. So you've got a local lib and it's got stuff in it. Yeah, okay, in theory, somebody may have used Carton. Do you want to bet on that? Do you want to bet that nobody has forgotten they were using Carton and installed the package manually? I don't bet on it, believe me. So, all right, we need to figure out what's in there. So, my first thought when I was looking at this problem was, what about perl-local.pod? Because, you know, that lists everything that's been installed, provided it was installed with MakeMaker. It is not possible to have a module build free dependency chain. As such, perl-local is useless. So what do? Well, you can go groveling for packed lists, but they only tell you what files. You can go parsing into the package files, into the actual files, look for package declarations. Okay, there's modules to help you do that. That's great, provided you've only got pristine versions of distributions rather than maybe a patched version. Again, don't assume that hasn't happened. And then it gets into all sorts of horror and fascination. Fortunately, Tim Bunt's already plumbed the depths of this horror and produced a thing called Disk Surveyor. And Disk Surveyor, through a combination of parsing shit, calling out to the Meta CPAN API, and some fairly inspired heuristics and guesswork, will come up with a pretty solid list of everything that's installed. The warning here is it does this by doing clever things, and this is very good, but it means it takes a while. Disk Surveyor is not something that you run and get an immediate response back from. It's something you run and go for lunch. Or better still, run in an automated process so it does all of the machines overnight. Something like that. But again, you can get the information out of it. So now you know where the code is. Great, all easy now, yeah? Hang on a minute. What servers talk to which servers? Well, what are the dependencies? We don't know. Okay, so you need to enumerate the running services. Now, okay, init.d and rc.d in an ideal world would be sufficient. Except, well, you know, people may have deployed stuff under daemontools, under runit. They may be using ubic. I didn't put onto the slide the traditional favourite of, oh look, this production service runs under screen. Excuse me, I'm just going to take a swig of coffee to clear up the taste where I threw up in my mouth after saying that. So basically the only thing that you can trust is PSAX. Seriously, get the process list, apply LSOF, apply netstat. That's going to tell you what daemons are running, what files they're using, and what network connections you've got up. What files they're using is fascinating. Do that on a running MongoDB instance sometime. When you stop screaming, I'll buy you a beer. Anyway, and you can also dig into /proc, which is fine, assuming you're on Linux. /proc is great. If you're on other operating systems, it may or may not exist. But honestly, whatever works. You just want to be able to get the data, because that should give you an idea of all running processes, all files, and all connections. And now you start cross-referencing. Basically, you snapshot all of that information on the system every 5 or 10 minutes for sort of 2 or 3 days, merge it together, and then start going through and figuring out how everything talks to everything else. Dumping the output into a wiki page is a really good idea, because it's easy to view and you get free history on it. The Media Wiki API works fine. I gave a talk last year about a thing called System Introspector that drives the Media Wiki API to produce reports. We've been using that a lot. We also dump the output into a Git repository because JSON : diffable is your friend. It's very simple. All it does is it adds trailing commas, which you can still parse in relaxed mode, so you can load it back in fine, and the addition of the trailing commas means the damn thing diffs properly. At which point you can apply diff, log, and blame to watch the information you're gathering changing over time. Grep out the things you recognize, look at the rest, figure out what it is, repeat. Again and again and again until you actually recognize everything that's running on your system. Bonus points can be earned here by discovering that one of the things is a botnet because somebody forgot a security update. By the way, all these bonus point things, I've scored at least once. Anyway, so now we know what talks to what and why, and you've actually got a diagram of your overall architecture. You now have the documentation that you would have had, you planned to have originally, but never got around to keeping up to date. And better still, because you inferred it from the live system, you actually know it matches up to reality, which is, normally not true of any documentation anywhere. So, one more thing. Grep anything that looks like it might possibly be a config file for IP addresses. This is an important step, because there will be one somewhere, and you are not going to be able to migrate anything if you've got hard-coded IP addresses and stuff. That is going to screw you at some point. Really, no matter how careful you think you've been, there will be one somewhere. Just grep for them. It's not difficult to get to find a regex that matches dotted quad IPs. Depending on how insane your internal networking is, you also may want to find a regex for IPv6 addresses. But my experience so far is that I've never seen a raw IPv6 address in a config file because the hostname's actually less typing. So it doesn't have quite the same appeal to lazy people in a hurry that IPv4 does. And then finally, step 3 of this part of the process, go and find a beer to cry into. You deserve one at this point. Okay, so that's the discovery process. I want to go back to this quote for a moment, because the guy who came up with that was Bill Walton, who his IRC nickname was Wild Bill. So that's the index in my head. Remember, I can't do real people names. I index people by IP addresses, not IP address. IRC nicknames. They both start with an I. What? Evidently, I need more coffee. Moment. No, seriously, I index people by IRC nick and email address. It works better for me. But anyway, so Wild Bill was a manager with a customer of ours. And also, mad Texan bastard. Great fun. Came up with used to come out with a lot of these metaphors. And lent very heavily on the folksy. Specifically because that makes them much more memorable and much more accessible. I mean, the point at which I realized I was going to enjoy working with this guy was when on the original call with me, him, and MDK, his comment about what happens if you let a salesman manage a technical team was... I can't do the Texan accent, but it's the he couldn't find his ass with both hands and a hunting dog, and you're just like, right, yeah, I'm gonna like working with this guy. He also rather than going, I understand this, stop treating me like an idiot, even if I do have manager in my title. That comment got deployed a few times to remind me I didn't need to be quite so detailed. Yeah, but there's a serious power to this sort of stuff, because that sort of metaphor is accessible to managers and to technical staff. He's the only person that I've encountered in a while who can come up with one line that sticks in the head of the business side and tech side of a meeting, and I encourage you to try and steal this approach, because it's a very effective thing. And when you're trying to get time to do the fixing of servers, that needs doing to not need to be firefighting constantly. It's quite difficult to explain to people, yes, production outages will be slightly longer because somebody is focusing on making them go away forever, but that's how you have to invest the time. You know, we have some technical debt is not an accessible statement. Whereas this is a swamp, yeah, most people get a visceral understanding of that one. So I say thank you for him to inspire the talk. And the other reason is this has not been a good year for people getting cancer. So sadly, rather than meeting him for a beer after this talk and getting to thank him for stealing it, all I can do is dedicate the talk to him. Oh. Moving on. So we now have a good idea of what systems we have, what packages, what code, what services, and what their dependencies are. Okay, cool. So now you can start planning. The first thing, seriously consider using fresh machines if you can. If you're on a cloud provider, then it's just sensible. If you're in a colo, see if you can negotiate with them to basically sort of daisy chain moving machines along across hardware. Just because your existing systems are bound to be missing security fixes. They're bound to have had odd things done to them at some point. That all of that investigating you did last time missed. And it's generally best to assume the worst and try and start greenfield to produce something that you know is under control. But, the point is, a fresh install, you know exactly what's on there. Not knowing exactly what's on there is why you currently have a problem. So it's very much worthwhile if you can do it. If you have to do it on machines in place, it is possible to do say a debootstrap and then pivot root into it without actually taking the system down. This is an interesting exercise and requires quite a lot of coffee and strong nerves, but it is possible. But I'm suspecting that in a lot of cases you'll be able to use fresh machines. If you can, just do that. It's just so much easier. And now it's a question of take problems one at once. So one service at a time. Don't try and move two things at once. Never try and move two things at once. Anytime you try and move two things at once, they will both break. It is guaranteed. Another thing to bear in mind is firewalling isn't just a security measure at this point, right? Restricted firewalling is a really good way of keeping you honest. Because if you have a machine that you didn't think, if you have an interdependency you don't know about, the firewall, a strong firewall policy is going to make that break, at which point you'll notice it, as opposed to it going unnoticed until some point later on when it wakes you up at 3 a.m. So approaches to automation. I am not actually going to express much of an opinion apart from pick something pull-based. I don't care what. Honestly, just find something pull-based that makes sense to you. Overall, sysadmins seem to prefer Puppet, and developers seem to prefer Chef. Overall, that's not like a strong thing. There was a long discussion internally at Shadowcat between a dev who'd been reading through the Chef docs and a sysadmin who'd been reading through the Puppet docs, and they basically concluded that the core feature set is about 95% identical. And at this point, you're not trying to do anything clever. You're just trying to get the basics under control. So, and there's other options as well. Find one that makes sense to you and go for it. The important thing is to have one at all. And the essential thing is make sure it's pull-based. Do not, if you can possibly avoid it, rely on a push-based management approach. Because the thing is, pull-based systems converge. Pull-based systems always basically tend towards being in the right state. If a system's down when an update goes out, a push-based system will miss it. If there's a network blip, a push-based system can miss it. If the system's just too overloaded to apply the thing, again, a push-based system can miss it. When you add a new machine, well, that's never seen any of the pushes, and you have to remember to run it. Whereas if you're using a pull-based system, worst case scenario, half an hour later, it picks up the update anyway. So just push-based is going to give you more problems, and most of the pull-based systems now have a way to kick it and say, please update immediately rather than the next time the cron job runs. So you can get 98% of the way to push, but still get all the advantages of pull. So yeah, I'm not going to get into holy wars over this, because my current point of view is I hate all of the current systems automation things. But that's the Perl hacker in me wanting to write yet another one. For the purposes that we are facing at the moment, heck, I mean, there's a Perl-based one called Slaughter that apparently works reasonably. There's CF Engine. There's BCFG2, which has the most heinous config file syntax you will ever see in your life, but actually works really well. There's Rex. I read the source code to Rex once. Then I went and read the PHP BB2 source code to cleanse my brain. On the other hand, again, it works. You kind of. I mean, I suspect if I read Ruby as well as I read Perl, I'd probably find some howlers in the Ruby ones as well. So, yeah, just Google pick something. It'll be fine. Configuration generation. Okay, they can. Whatever tool you picked can probably drive templating, but it can also almost certainly call scripts. So there's absolutely no reason to convert to their templating system. If you know TT, just use TT. Also, then you end up with a small Perl script that you can hook into a makefile or a distiller build or whatever, and run on development side. Because you don't really want to run your full systems automation to set up a dev instance, but you probably do want your dev instance's config files to be generated the same way. So have a think about that, and again, pick something that works. It's a lot easier to replace a systems automation architecture with a better systems automation architecture than it is to get the first one in the first place. And that's very much the focus here. The other thing is, through this entire process, there is an important rule of thumb. Do not be clever. Clever leads to exciting. Being paged at 3 a.m. is exciting. But it's not what you were looking for. I end up saying this to developers over and over and over again. If this is a systems problem, you appear to be trying to be clever. Stop now. You know the old adage. You need to be twice as smart to debug something as to write it in the first place. Bear in mind that systems problems always happen at 3 in the morning. So you need to be not only twice as smart, but twice as smart when you've just been woken up at 3 a.m. This indicates you need to stick to at most about 25% of your intellectual capacity in terms of the original design. Any more than that is too much clever for systems, okay? So, step 0. Kill with fire those IP addresses you found earlier. Seriously. I don't care if you have to do that part manually. Do it first. Just seriously, do that part first. Otherwise, you will forget, and it will shoot you in the head later. If your DNS is a mess, and that's one of the services you have a problem with, okay. Choice 1 is fix DNS first, but often that's kind of a scary thing. There is an alternative. It is a stupid alternative, but it works. Build a host file, rsync it to everything. Better still, build a host file, set up a cron job that pulls it via rsync every hour or so. Again, stick to pull-based if you can. I know that's a horrible thing to do, but if it's a choice between not knowing whether or not the wobbly DNS is what's causing your current problem, or whether something you just did is causing your current problem, I'd rather have the rsync host file. Yeah, it's always a question of trying to minimize the unexpected ways things can go wrong, because you're in a situation where there's plenty of expected ways. Okay, so step one, back up everything. Yeah, somebody always says this. You're right. No. And even if you think you have backups of everything, you won't have tested them. And believe me, at the point at which you start trying to apply backup everything to EC2, you discover all sorts of interesting things about EBS volumes. For values of interesting that might relate to a certain Chinese curse. All hardware sucks, all software sucks, and at web scale, the suckage is distributed, clustered, and sharded. So go check, verify you have a recent backup of everything. Once you've done that, build new machines with the config stuff, restore the backup data onto them. This also means you've now actually tested restoring your backups. This is the step people often miss. They know their backup process backed something up to somewhere, but they've forgotten to check that the contents of that actually constitute a viable backup. Yes, I've been guilty of this. No, that was not a funny day. And then the other thing is, now you've restored a snapshot, you can point a development machine at the new systems and check that everything works. And it's fairly important to do that from a backup snapshot, because unless you've got a complete set of production data in there, you don't know for sure that those systems will work with a complete set of production data. Which it's a very different thing to the sort of thing to your usual test data load. Then you make a modification, assuming it's clustered or you're using slaves or whatever. Go and check that the change made it all the way to the slaves. By hand if necessary, I don't care, but check. At that point, you've got a proof of concept for this new service architecture. Only at that point. Now you've done that, you need to. It's time to think about migrating it. This is the point where you need to develop a migration strategy. If it's a customer-facing service, it's probably over HTTP at this point. There are exceptions to that rule, but 99% of the time, customer-facing stuff is tunneled over HTTP one way or another. Now, okay, if you have load balancers or whatever, there's various things you can do to migrate quietly. But assuming a worst-case scenario, you may not be able to do that. And of course, there's always the fun of moving the load balancer. First rule: do not trust DNS timeouts. Dropping a DNS timeout low to be able to do a migration is a great idea in theory, but in practice, you will have customers who are behind an ISP who's caching DNS servers don't honor timeouts when they get too low. I found this out the hard way back when I was ISP operations, when I discovered that British Telecom, which is the equivalent of the old AT&T monopoly over here, didn't honor DNS timeouts at all. They just cached everything for a day. BT ex-monopoly used to be run by the government, now run by even less competent private owners. Fear and loathe accordingly, really. If anybody wants to be seriously disturbed, ask either Chris Nairn or I about some of the war stories that we've got from trying to deal with BT systems. Mine from back in my ISP days And from his Shadowcat days, because I went, this project involves dealing with BT. Delegate! Anyway, so, don't trust DNS timeouts. They're about as useful as a referrer header, seriously. Instead, embrace the wonder that is World War II. Start off with your service is live on World provision World War II. Now, you set that up on a new machine, and you set it up with a redirect across to World War, right? That's your step one. Now, you wait a day or two so that World War II's DNS is reliably propagated. Now, once you've got World War II ready, you flip the redirect around. So everybody hitting World War gets redirected across. If it catches fire, you flip the redirects back around again. Everything works. Everything goes back to the old thing. This is the other thing. At least one of your migrations is going to result in it breaking. Don't push onwards. Flip back to the old one. You might lose a few seconds worth of writes to the database that way, but at least your service is back up again. Then figure out what went wrong, then start it again. Don't just try and power through, because that results in you being sleep deprived, and it's still being broken in obscure ways when your customers wake up in the morning and get very, very, very upset. One of the reasons that I am so fond of pulling all-nighters and have such a horrible caffeine addiction, even 10 years on, is that the upper management back at the ISPs that I worked for did not understand this rule. Anyway, and now you're going to have to wait again because you're waiting for things to settle. And bear in mind at this point, you can always switch back to the old web cluster because it's still there. I have on occasion had managers go, but why are we paying for 2 sets of servers? How much money are we going to lose if this breaks and we don't have a way to go back? Oh. Alternatively, if possible, just tell them this is how we're doing it, this is the plan. In my experience, an effective relationship between management and a technical team mostly consists of both sides not telling the other side the things they're not going to understand anyway. Now, so assuming it now it still hasn't fallen over. At this point, you can flip the DNS entry for the primary one. You may wish to consider having it somewhere along the line added an extra one, maybe 3, that points at the old cluster just in case. I usually don't bother. By this point, either it's going to work or it's not. And yeah, you have to wait again. Now, your final step is to flip the World War II redirect to point back to World War so that everybody converges onto the right host name on the new location. And yes, the next step might be kind of familiar at this point. But at that point, you're done. Yes, this is an incredibly boring process. Yes, it's dumb as a post. But this is systems. Exciting is 3 AM pages. Boring is happily running systems. Internal services present a whole different set of fun. Okay, you can trust DNS, but at this point the service is probably a database server or whatever, and now it's stateful. Okay, so most such systems do master-slave, do clustering. MongoDB does writing to dev null at web scale. Somebody did actually put a small Python thing up on GitHub called MangoDB that literally writes to dev null. It's marginally easier to administrate, but very similar in the results. But anyway, so, okay, in some cases, you can use switch across, promote a slave to a master, and slave chaining. Now, all of this stuff is great in theory, but in practice, sometimes it's a bit complicated, and also, it requires you to be doing configuration changes to the current live things as well as to the new stuff. That always worries me a little bit, because once you fail over to a new master, trying to get the old master back to being master is often something that the cluster hates you for. I will state for the record that I have seen probably 5 times as many outages caused by intelligent failover systems being overly clever than I've seen caused by manual failover not happening quickly enough. Seriously, a lot of the time, if you have a master machine and a slave machine, say, you're much better off having good monitoring that pages you and going and looking at it and manually failing over to the slave, because that will probably actually cause you less downtime than trying to have automatic failover and risking split brain syndrome and all of the other hilarities that can happen at high scale. Obviously, if you've got several hundred machines, that's not an accurate approach. But if you've only got 1 master and maybe 2 slaves, seriously consider just going for the dirt stupid approach. So here is the stupid way of doing data migrations. It is based around our old friend rsync. Really. What you do is you run rsync, and then you run rsync, and then you run rsync. I'm not joking here. I might be joking there, but not entirely, because what you basically do is you rsync it, and you rsync it, and you rsync it, and you keep repeating. And at some point, the rsync will get to under about 5 or 6 seconds, yeah? At that moment, you go into crazy mode. Stop all of your services. Stop anything that's dependent on it. Change DNS. Rsync 1 final time. Start everything back up again. You just migrated without any cleverness, without any risk of things going, oh, can't figure out which is master or which is slave or any of that. And if it goes horribly wrong, remember, you're in a situation where you can synchronize in a handful of seconds. So you stop everything again, rsync back, and bring the old cluster straight back up again. It's a hair-raising experience doing it, but it puts you absolutely in control of that switchover, and it gives you an easy way of going back. And that seriously can save you. Yeah, it sounds kind of horrible. Yes, it's completely brute force, but it's completely predictable, and it does exactly what you expect it to do. And a lot of the time, especially when, part of the thing is you're not entirely sure you like the configuration of the old cluster, it's just easier to do it this way, seriously. The other crucial thing is, yes, you're going to have an outage, depending on, getting it to under 5 seconds might be optimistic, depending on your write load. But you've got a relatively short outage window, and you've got a pretty much guaranteed it will be this long outage window. Whereas cluster trickery and slave trickery, in my experience, 4 times in 5 is 0 outage, and then 1 time in 5, everything melts. And I don't know if anybody's ever tried to patch MySQL or Postgres replication to get back together by hand with a hex editor. All databases are evil. Everything, it all hates you, and it all wants and wants you to have a bad day. So, whereas this is the thing, rsync is predictably horrible and doesn't require a sand check to avoid summoning Cthulhu. Pick your poison. Step 4. Hopefully, go find a beer to not cry into. Although, generally, you should be doing this on a Monday. That gives you the rest of the week to fix things. If you migrate services on a Friday, I am going to spend the entire weekend laughing at you while you try and fix the problems. Because, really, it's going to happen. The only reason to migrate something on a Friday is if you're planning to spend the weekend in the office fixing the problems in the hopes that they'll all be fixed come Monday morning. This is a valid approach, but make sure you get overtime for it. At this point, pick another service, repeat, keep going. Don't overcomplicate things. This should not be rocket surgery. If you can avoid it being rocket surgery, then it's fundamentally just one dumb migration after dumb migration after dumb migration. And at some point, you'll suddenly notice there's no swamp anymore. I'm afraid, I don't really have a big bang ending to this talk, because the whole point of it is to get rid of big bangs and explosions from your life. Keep it simple, keep it stupid, keep going, one alligator at a time. Thank you very much.